Life is short, and you don't want to spend your whole life graphing. If you made it this far, you know how to solve linear systems by graphing. It is the point where the two lines cross. But I'm going to show you an easier way, and it is called the substitution method. And as it implies, I'm going to take the top equation, and I'm going to do 2x plus y is equal to 3. And I'm going to solve for y, minus 2x minus 2x. And I'm going to write y is equal to negative 2x plus 3. And I'm just going to substitute this equation, because y equals that. I'm going to put it in to that y. And I'm going to solve for x. So I have, I'm going to switch colors, getting close to Christmas, so let's do a little red and green. I have 4x plus 4 negative 2x plus 3 is equal to 8. Okay? And now I can solve for x. The next step, I just distributed the 4 across both those terms. Next step, combine like terms and subtract the 12. So we've got negative 4x is equal to 4. We find out that x is equal to 1. X is equal to 1. Okay, so we have the first solution for the point where the two lines cross. And I'm going to go ahead and put this in that ordered pair over there. And now that we know that x is 1, the rest is easy. I'm going to substitute 1 in for x. So I'm taking the top equation again. I can use either equation, it doesn't matter. You're going to have the same solution. And I'm going to put 1 in, plus y is equal to 3. 2 times 1, we've got 2. And plus y equals 3. And we find out that y is 1 as well. And that means that these two lines are crossing at 1, 1. Now let's look at this equation, and what's going to happen with this equation is if I substitute in y, so I put this equation, I put this in for this y, and if we solve it for x, we wind up with something that looks pretty strange, because if we combine negative 6x and 6, we get 0, and if we add the 8 on both sides, we get 0. 0 does equal to 0. We're coming back to when we were looking at these in one variable. This is going to be infinitely many solutions. Alternatively, if I put this into point-slope form from standard form, then you have the exact same equation. In other words, one line is on top of the other line. So these two are going to go together for infinity. One line's on top of the other line. They're both crossing at 4. The blue one is crossing at 4. It's dropping 3 and going over 1. And the red one is crossing at 4 and it's dropping 3 and going over 1. Therefore, that's kind of a bad line, but hopefully you get my point. Therefore, the solution is infinitely many solutions, because these two lines are going to be going on one on top of the other for infinity. However, if you have a situation like this, if I put these both into into slope-intercept form. If you look at these two equations, they have the same slope and they have different y-intercepts, okay? The top equation is going to be crossing through 2, and I'm going to make these spaced pretty widely. And it's going to be dropping 3 and going over, it's going to be dropping 3 and going over 4. So it's something like this. And the other one is crossing at 2.25. So these are never going to touch. Sorry, that's supposed to be a line. They're never going to touch. They're going to go for infinity without crossing. Therefore, because they have the same slope, but they have different y-intercepts. So that is no solution. Okay? So if you get a scenario like that, then it's no solution.